Hey, welcome back, math friends. Today we are taking a look at topic 15, block 5, cylinders, cones, and spheres. And we are going to talk about the volume of a sphere. Now you're going to need your math book, and you're going to want it open to page 495. So if you don't have your math book, go get it and open it up to page 495 after you pause the video. All right, good. Now that you've got your math book, first question, what's the volume of a sphere with a radius r? Well, before we even answer that question, we're going to go take a look at some information that you're definitely going to need. So, we found that cylinders and cones are related, but how do spheres fit in? Well, we're going to play this animation and find out. Now, I want you to imagine that a sphere is made of thousands of skinny little pyramids, each with their tip at the center of the sphere. You can see those things filling in all around inside that sphere, all the tips pointed in, all the bases around the outside. Pretty impressive, right? Of course. If you could find the volume of each pyramid, the sum of all the volumes of all the pyramids would equal the volume of the sphere. Remember your equation for a volume of a pyramid? Maybe you do, maybe you don't. Remember, it was 1/3 the area of the base times the height. Or 1/3 great big B times R. And where did that R come from? The height of the pyramids is the radius of the sphere. Remember all those pyramids? All the points are on the inside there. So, the volume of the pyramid is V equals 1/3 the area of the base times R, because R is the radius, which is also the height of the pyramids, and B is the area of the pyramid's base. So the volume is the sum of all the volumes of all the tiny pyramids. So we've got the volume of that pyramid, the volume of that pyramid, the volume of that pyramid, and so on and so forth, the volume of all those pyramids. And remember, the volume of just one of those pyramids is 1/3 times the area of the base times the radius. And remember, the radius is the distance from the center of the sphere out. Now look at that. Volume is 1/3 of base 1 times the radius plus 1/3 the base 2 times the radius, 1/3 base 3, and all of those pyramids. It's crazy. So you can see that the terms in the sum have common factors, and each term has a factor of 1/3 and R. So if you factor out the 1/3 and the R, then the volume is equal to 1/3 times the radius multiplied by all the bases of those pyramids added together. So we use the distributive property to pull out the 1/3s and the radiuses. So now we can see that all those base 1, base 2, base 3, all of the bases of those pyramids, they all add up together to equal the surface area of the sphere. And we already learned how to find the surface area of the sphere. So, if we multiply 1/3 times the radius times the surface area of the sphere, that should give us the volume of the sphere. So the way they break it down for us here is, you can see the volume equals 1/3 times the radius multiplied by 4 pi r squared. And remember, 4 pi r squared is the surface area of the sphere. And so they do a little bit of multiplying through and everything. If you multiply 1/3 r times 4 pi r squared, that simplifies into the volume of a sphere is equal to 4/3 multiplied by pi times the radius cubed. And that's really important, so you want to make sure and write that down. 4/3 times pi times the radius cubed. That's the formula for the volume of a sphere. So, if you look at page 495, you'll see question number 1. What is the volume of a sphere with radius r? The volume of a sphere is 4/3 times pi times r cubed. So you'll want to write that down. Now, you should remember about cylinders. And you should remember about Archimedes. And Archimedes found that when a sphere and a cylinder have the same radius, the surface area of the sphere is 2/3 the surface area of the cylinder. He also found that the sphere's volume is 2/3 of the cylinder's volume. So, it's 2/3 the surface area of a cylinder. It's also 2/3 the volume of a cylinder. There's a very special relationship between cylinders and spheres. Now, if we use 3 as an estimate for pi, then you could say that when you estimate the volume of a sphere, it would be 4r cubed. And that's if you use 3 for pi. But of course, we want a more exact measurement most of the time, so we would use 3.14. But you can use 3 as an estimate to find the estimated volume of the sphere. And so that would simplify to 4 times r cubed. Now remember, when you cube r, the radius, that's radius times radius times radius. Not radius plus radius plus radius. The radius times itself 3 times. All right. Now the main focus of this display that Faye, they're calling her Bobby here, but Faye is going to create a solid sphere that she'll make by pouring molten metal into a mold. And she wants the sphere on the sculpture to have a diameter of 6 feet. So, we want to figure out what is the cost to make a sphere with a diameter of 6 feet when the metal cost is $100 per cubic foot. Now, we're going to estimate using pi equals 3, and then we're going to use a calculator to find the exact measurement using, or as closer, a more appropriate measurement using 3.14 for pi. All right. All right. I'm sure you can see now that I'm back on page 495. And question number 1, the volume of a sphere with radius of r. Of course, we know the formula is volume equals 4/3 multiplied by pi times the radius cubed. Now, let's answer this second question. With Faye planning to create a solid sphere she'll make by pouring molten metal into a mold, we want to find the cost to make a sphere with a diameter of 6 feet. When the metal cost is $100 per cubic foot. Now we're going to estimate using pi equals 3, and then we'll use a calculator. All right, so first the estimate. Pi equals 4/3 times pi, and they said use 3, times the radius cubed. Now, it says that it has a diameter of 6 feet, so that means that the radius is 3, and we're cubing that. So, this would be 4/3 times 3 times 3 times 3 times 3. 3 times 3 is 9, times 3 is 27. All right, now, what is 3 times 27? Find that out real super easy with a calculator here. 3 times 27 is 81. So this will be 4/3 times 81. And if we do this, put a 1 under the 81 now. 4 times 81 is 324 over 3, because we multiplied straight across. 324 divided by 3 is 108. So it's going to be 108 cubic feet. Then, if we multiply that times 100, it was going to be approximately $10,800. Hoo-wee! Holy moly. All right. Now let's find the more exact measurement. So remember, it's 4/3 times pi times the radius cubed. Okay, now that's 4/3 times 3.14 times 27. Now if we rearrange these, we can do 4/3 times 27 times 3.14. I'm going to multiply 4/3 times 27. 27 times 4 is 108. We know this. 108 over 3 times 3.14. 108 divided by 3 is 36. 36 times 3.14 is 113.04. So that's cubic feet, 113.04 cubic feet. So we came close with the estimate, but not close enough. Okay. All right. So if we have 113 4/100 cubic feet, we multiply that times 100. And that would be $11,304 exactly. Great. All right, so all you have to remember when we're talking about the volume of a sphere, it's always that lovely 4/3 pi r cubed. That's the volume of a sphere. Now, for the remainder of this assignment, after this video, you're going to work on number 3 in the book on page 495. You'll do number 4, and you'll notice that these are reviewing your skills about volume with cylinders and cones, and then we've got another sphere here, and I've got a question here, and another one, question number 7. And those questions you can answer in the forms document that comes with this lesson, but you could do the work in your book and then transfer your answers into the form. All right, well, there you go. Have a great day. Don't forget to be awesome. We will see you next time.